Hey everybody, it's me again. I wanted to give you another update on where I am with this Coco bus interface. Since the last time, I made some enhancements to the setup. You can see I made some small adjustments to the schematic as well to get what I wanted to do done. And I'm going to be incorporating those into the next version of the board. But basically, now I've got it set up so that it will work. As you can see, the color computer is on, so is the Arduino, and what I can do is when the Arduino wants to take over the bus, it can assert a line and essentially disable it. It's just like disconnecting the bus interface. So for example, if I wanted to go and verify the ROM, boom, it's done the verification. And since the color computer here, this one is a color computer 2, since it doesn't have any of that kind of copy ROM to RAM business, it was easier to test on this than the color computer 3. But since it doesn't access it, since it's just sitting there at the prompt, it doesn't even notice that the disconnect occurred. What that allows us to do is actually go and reprogram the ROMs if we want to on the fly. As long as it's not being actively used, it'll be fine. In this particular case, I didn't set it up so that it would boot directly, and that was because I wanted to test out the peripheral control. So to that end, I added this other capability here that I called slave mode. And what it does is essentially it sets it up so that it listens and waits for the SCS line to go down and then reads things. I'm still working out some problems with reading the address bus, but it will actually read the data lines pretty easily. So if I actually go and type in a poke instruction for HFF40, let's say, and let's say I want to do 3A. Okay, so I'm going to do that, and then when I hit enter, it should 3A. And if I say no, I want poke HFF41 H6D. 6D. So it's able to decode, like I said, and know that it's supposed to respond. The reads should work as well, but I haven't implemented the code to actually do the reads. So it would actually, when it saw the SCS signal, the Arduino would still try to read from the bus and it would just get garbage at the moment. It'll once I set up a couple of small changes, I'll be able to get that addressed. But you know, so far so good. And actually, one of the kind of nice things is since the ROM pack is actually still working, I should be able to say exec and there you go. It's running off of the ROM. You can see the LEDs here are actually the things that are actually doing the signaling, telling you that it has control. Now, interestingly enough, if I actually go and get out of slave mode and go into the ROM view mode, that's going to take over the bus, and the red LED down there is going to go, and that is going to super piss off the ROM that's running right now. So I'm going to turn on the view mode. You saw that little glitch there. So here is just a little memory navigator here. So at the 400, I can move 8 bytes at a time, or 2K pages at a time. It's kind of handy when I was trying to debug some things. So now it's no longer accessing the bus, but this is still pretty pissed off. So anyway, that's where I am right now. I'm going to continue to make some adjustments. I'm going to get bidirectional I/O working and finalize the hardware design. Might add some additional expansion capabilities on here too, thinking about different ways to enhance the peripheral support for the Arduino, or to integrate some of the Arduino components right now into this. The other thing I'm looking at doing for this design is these buffer chips. The two on the Arduino side are completely unnecessary as far as I can tell, and so I'm planning to remove them, and that should reduce the chip count and some of the complexity a little bit too. I believe I can eliminate that buffer chip as well, but I'm not sure. So more soon.